Feeling good about what we've been doing? Today's gonna be easy. All right, good morning, everyone. Today's Friday, September the 10th. September the 10th. All right, so we have day two of 1.08 today, slant, asymptotes, and holes. Little reminder that remember, guys, if you guys show up for the live lessons, please actually be here and participate. So, if you're going to log in and actually, well, not do any work, you can just watch the recording later. Because this way I get people that actually in live sessions that are actually going to participate and work out the problems with me and help me basically, right? All right, just a little recap of next week. So this is day two of 1.08. We have Monday 1.08 day three. Tuesday is the review for the unit. Wednesday and Thursday is your exam, part one and part two. And then on Friday next week, a week from today, we will be starting unit two. So we are getting pretty close to wrapping up unit one, which kind of feels good, right? All right, slant asymptotes. Now, somebody asked me yesterday about finding these, and I think I told you I wasn't sure if we are going to do them, but we are, and it's in today's lesson, along with the finding holes. So these are the missing two pieces. It's a math joke because on the graph they're missing also. Okay, bad jokes. All right, so make sure you get your paper, pencil, pen, and graphing tool like Desmos. All right, so today's gonna be very simple. If you remember how to do synthetic division and especially long division, we'll be using this. So we'll be doing division when calculating our slant asymptotes, SA for short. All right, so this problem right here, slant asymptotes, this is a very important page. What's bolded and underlined? It says slant asymptotes, SA for short, only occur when the degree of the numerator is one more than the degree of the denominator. So that means that not all rational functions will have an SA. It only happens when your degree in the numerator is one higher than the degree in our denominator. So this is a 1, right? Invisible 1. This is a 2. 2 is definitely one more higher than the 1. So because of that fact, we know this has an SA. All right. Just to check, make sure we're all listening. Does everyone understand how to determine whether a rational function has an SA or not? All right, so one person said no. I'm guessing they just tuned in, so I will say it one more time for a person who just logged in, it looks like. All right, so a graph has a slant asymptotes. Remember, an SA or a VAHA, those are lines where your graph will not touch or cross over. So we know that a rational function like this one I graphed here, which is this function, we know this has an SA when the degree in the numerator is one higher than the degree in the denominator. So this is a 2, this is a 1, this is one higher than this. So this tells us that this function, when graphed, in fact, does have an SA. All right, Aiden, you good now? All right, welcome to class. Okay, so once we establish whether the function actually has an SA or not, we have to calculate it. Now, we have to either use synthetic division or long division. So ideally, something like this, like if our denominator is in the form of like x plus or minus a number, immediately we should think, oh, thank goodness, we can do synthetic division. It's faster, right? So what you do is do synthetic division, the numerator divided by denominator. I didn't show the work, but I will show, we will do some problems in showing the work, but I just have the answer for this one. So this divided by this, we get this. We get 5x plus 5, remainder 3. So we got, 5x plus 5 plus 3 over your divisor. Jeez, trying to blank. So the slant asymptote, the equation, is just the non-remainder part. So we get remainder 3 when we divided this. So we just ignore that for the SA, and we just pull out the part that is the non-remainder. So our SA is y equals 5x plus 5. And the nice thing about these, if you're really unsure if you did it right or not, just graph the original function like I did here, and then graph your SA. And it should make this nice slanted line that kind of glides along the border of your graph. And this shows that your original graph, it can get really close to that SA line, but it'll never touch and it'll never cross over. And we can zoom in Desmos and really see that in action. All right, how are we doing so far on the idea of finding the SA? We'll do some in here in a moment. All right. So if you got some awesome division skills, this is going to be walk in the park, a very safe park, right? All right. So here's I have 4 examples here, 5 through 8. Let's take a look at number 5. All right. So first, we have to determine so in chat, everyone can respond. Does this function, this rational function, does it even have an SA? Yes or no? So we got a lot of yeses. And how do we know it has an SA? The degree of numerator. Well, no, be more specific. So yeah, so Philip and Noah, with your minds combined, you got the right answer. So the degree of the numerator is 1 higher than the degree of the denominator. So Lilani in chat said that very nicely. So yeah, so like if this was an x cubed and that was just an x, that would be 2 higher, and because that would be an x cubed, and that's an x to the first, then that function wouldn't have an SA. So you really need to make sure you check, is this only 1 higher than this power? And the answer is yes. All right, so everyone, quickly on your paper, do synthetic division and find me the SA. Ready, go. Don't forget placeholders. Yep, even the constant needs a placeholder. All right, everyone. So in chat, go ahead and write the equation of the SA, please. Remember, I just want the SA equation. Just the SA equation. So looks like people in chat who have written it out got it right. Y equals 5x plus 1. So yeah, this is, remember, when we divide, the answer is 1 less power, right? So this becomes 5x, and then there's your constant, and then there's your remainder. So the SA is y equals 5x plus 1. Remember, we don't care about the remainders. It's the non-remainder portion for the slant asymptote. And of course, remember, we can always graph this function in Desmos and then graph this line and see if it looks like it's correct. And it is, right? All right. How are we feeling about this one so far? Actually doing the math and identifying the SA. It's not too bad, right? If you can do division, this is not bad. Yeah. Long division problems, I don't like them. Most people don't like them. So like this right here, this would be long division. So again, determine does it even have an SA? And well, class, this has an SA, right? That's a 3 and that's a 2. Yeah. Yeah. So because it's not in the form of x plus or minus some number in our denominator, we can't use synthetic division. So we have to use long division. Don't forget your placeholders. You also, I don't know if you, hopefully you worked out the different examples in the modules when we did long division and synthetic. But it might be a good idea that if you need placeholders on the outside, on the inside, definitely you need them. But on the outside, it might be a good idea to also have placeholders. It might make everything just line up better without much thought. But you definitely need placeholders on the inside if you if we need them. The outside is really kind of preference, but might be a good idea to avoid mistakes. But anyway, all right. So everyone, quickly do this division, and then I'm going to give all of you. Let's see if you can do it in a minute. Let's see if you can do a long division problem in 1 minute. And again, if you are up to speed with the content, you went through all the examples in the practice and learn modules for synthetic and long division, you should be feeling pretty good about doing a problem like this. Yeah, so guys, this class is only going to be hard if you actually don't do work in it. Pre-calc can be very easy if you actually do what I tell you to do. Watch the recordings, come to live sessions if possible, work out the examples in the learn and practice modules, use all 3 attempts on quizzes, talk to me for if you need any help, especially on before doing your 3rd attempt on quizzes. All those things. If you do all those things, you're going to be just fine in pre-calc. I really do believe that. Like I've had people last year get 100% in this class, both semesters. Now, those very few people, they came to every live session. They always went through the modules. They always asked for my help if needed. So they did everything they should have done to learn the material and get 100%. All right. So anybody in chat know the SA equation? So we got Noah says y equals x minus 3. Anybody else? And 1 minute may not have been enough. I wouldn't blame you if you didn't finish this problem in 1 minute. Ah. No, guys, keep going. I'll wait for another 1 or 2 people to confirm or refute his answer of y equals x minus 3. We got a total of 15 people in chat. So, I want to get a few more people that can confirm this answer. So I see a few people are tabbed out. Aiden's tabbed out. Let's see what else we got. Phillips tabbed out. I'm just saying that just to make sure that you're here and working on it. And maybe you're in Desmos graphing it, and that's fine. You don't have to explain why you're tabbed out. I'm just want to make sure you're still here. All right, Lalani got y equals negative x plus 3. Ryan got y equals x minus 3. Looks like we are kind of... Okay, so Ian got y equals x minus 3. So we got some disagreements. It looks like we all agree that it's an x and a 3, but whether x is negative or positive or 3 is positive or negative, looks like we're kind of split. We got another y equals x minus 3. And again, like guys, on your quiz, on your test, given that answer, you wouldn't just stop and go to the next problem. You would go to Desmos, you would graph the original function, and you would graph what you think is the answer to verify it's correct. And then you'll be able to see real easily if that answer is right. So let's talk about long division. It's not, I'm not a really big fan of it, but um, you should be able to do it. So we look at the x squared and the x cubed. What times x squared is x cubed? Well, x. X times x squared is x cubed. So I'm going to write an x in my x column, which is right here. And then we just multiply. X times x squared is x cubed. X times 4x is 4x squared. And then x times 2 is 2x. All right. So a little refresher. Once I write all those, what do I do? What's my next step? Flip the signs. Very good. Very good. Yeah, don't forget to flip the signs. If you notice, I didn't write plus signs when they were positive. Well, they're all positive. Because I know that I'm going to have to flip the sign anyway. It just looks nicer if I just don't put the plus signs, right? So we flip the signs. And they were all positive. They now become negative. And now we just do the math, right? X cubed minus x cubed cancel out. X squared minus 4x squared is negative 3x squared. And then negative 10x minus 2x is negative 12x. And then we carry down the negative 2. All right, and then the problem starts over. So I ask myself, what times x squared will give me negative 3x squared? Well, I do think it's negative 3, right? Yep, negative 3. So we then do negative 3 times all three of my terms in my divisor. So I get negative 3 times x squared is negative 3x squared. Negative 3 times 4x is negative 12x. And then negative 3 times 2 is negative 6. All right. From this step, what do I do? What do I do again? Flip the signs. Yeah, flip the signs. So this one becomes a positive, becomes a positive, becomes a positive. And then, negative 3x squared plus 3x squared cancel out. Negative 12x plus 12x cancels out. And then negative 2 plus 6 is positive 4. So we do get remainder 4. Now, class, when you find the SA, could I have really stopped like right here? Did I have to really go on? Yeah. So yeah, so we can see right here, right? Once you have this number filled in, anything after this number is the remainder. So, I really didn't even have to multiply this negative 3 out to here. This is assuming that this number is actually correct. By showing my work, it just confirms that negative 3 was the right choice, right? Because these cancel out. But yeah, I didn't have to do this line or lower because anything after that is the remainder. So yeah, so the SA is y equals x minus 3. So y equals x minus 3. So give yourself a pat on the back if you recall how to do long division, you got the correct answer. All right, long division is fun. So that was a good refresher, right? Correct, Ryan. Yeah, so we don't have to do anything with the remainder. For finding a slant asymptote, we only care about the non-remainder portion. Yeah. Yeah, so again, remember The equation of our asymptote, the slant asymptote, the SA, is the non-remainder portion. All right, let's. And so this problem here, I went ahead and if you didn't go to Desmos and graph it, this is the one we just did. This is what it looks like when you graph it. It has these three different segments, right? And then we said our SA was y equals x minus 3. So when you graph it, we can see that this glides along, but it doesn't touch the graph, and our graph doesn't cross through it. So this is good. Now, if you graphed like negative x plus 3, I think I saw somebody put that answer. Your answer would definitely pass through a line, right? It would pass through the graph somewhere. That tells us it wouldn't be correct. If you put y equals x plus 3, well, this would just be shifted up 3 units, and it would definitely pass through the graph, which would tell us it's not correct. So yeah, graphing is definitely a very good visual way to confirm the SA is correct. All right, how are we feeling about finding the SA? Yeah, the idea is not, the idea is easy, right? But long division could be a little tricky sometimes, especially if you haven't had the practice. All right, let's see how much time we have left. All right, we got about 35 minutes. I do have more examples finding SA. Let's come back to these because I want to talk about, unless you guys want to do one more. You guys want to do one more? Like this one? Let's do one more and then we'll go and do holes. How about that? Let's do one more. I skipped number 7. I'll come back at the very end to kind of show you guys so you can come back during the recording and check it out. But let's do number 8. Only because number 8 is long division. Number 7 is synthetic division. And, we all know long division, well, takes longer to do. So I already set it up for you, the dividend and then the divisor. So let's see what you can all do. Let's see if all you can find our SA. So I will give you, I think 2 minutes, right? Hopefully 2 minutes. Yeah, I think once is not enough. So 2 minutes. Ready to go. All right, let's see. Those of you who are able to finish on time, 2 minutes. What did all of you get for the SA? So we got 2 people, y equals 4x plus 3. Anybody else? So we got y equals 4x plus 5. another y equals 4x plus 3. So we got a y equals 4x minus 5. All right, so we've got three different answers so far. One of them is probably correct. I think, it looks like we're all in agreement that 4x is the first one. The nice thing about, so getting the first one, and let's say your constant is wrong. Like I see, we got plus 3, plus 5, minus 5. If you go to Desmos and you graph them both, remember the constant just does a vertical shift. So if it's passing through your graph, you could just kind of mess with that constant to shift your slant either up or down until it looks like it fits. That's a kind of a way to partially guess and check. So we got another y equals 4x plus 3. So I'm going to quickly just go through this and figure out what the answer is. So I think, we're all in agreement that 4x. Okay, my pen wasn't working. I think I ran out of ink. All right, 4x. So we do 4x times 6x squared is 24x cubed. 4x times negative 6x is negative, well, same thing, negative, in this case, 24, negative 24x squared. And then 4x times 6. Oh, it's all, okay, 24. I was confused. I feel like getting 24 3 times in a row just looks weird. Anybody else thought the same thing? Yeah, so, and it's positive, right? So from this step, what do we do? Probably like the most important step. What do we do? Yeah, flip the signs, right? Flip the signs. I'm gonna use red. So it becomes a negative, becomes a positive, becomes a negative. So again, you probably noticed that whenever I get a positive, like 4x times 6 is positive 24x. I don't put the plus sign because I know I'm going to flip the sign. So I just leave it blank and I just put a negative when I flip the signs. Maybe do the same thing. All right, and then combine 24 minus 24 is 0. Negative 6 plus 24, I think, is 18 maybe. What's 18? Is it 18, everyone? Math is hard sometimes. And then 6 minus 24 is, I don't know. What is that? Negative 18? Yeah. And then we bring down the 28. All right, and then it starts over. What? So I'm gonna get my little pointer out. So what times 6x squared is 18x squared? Well, 6 times 3, right? 6 times 3 is 18, I think. So that means we've got a plus 3 right here. And then really I could stop here, but I'm going to show the work to make sure that 3 actually works properly. So we do 3 times 6x squared is 18x squared. 3 times negative 6 is negative 18x. And then 3 times 6 is positive 18. And of course, don't forget to flip our signs. We're doing long division. Becomes a negative, becomes a positive, becomes a negative. And then combine. So 18 minus 18 is 0. Negative 18 plus 18 is 0. And then 28 minus 18 is 10. So we get a remainder 10. Not that it matters for this problem, but we only care about the non-remainder part, which is y equals 4x plus 3. Now, people who didn't get this one right completely, did you see your mistake of maybe small or big, what you did wrong, and able to fix it? Yeah, and that guys, it's okay to make mistakes. Because we learn from them. So if you're making mistakes now, you say, "Oh, I did this. Hopefully, I don't do it again." So it's good that you're working these out with me and you're identifying your mistakes, because just watching me do this, you can your brain and you will convince yourself, oh yeah, I can do this. Oh yeah, I know the next step. Oh yeah, I totally do this. But what about when you're actually doing it by yourself and you're not watching somebody who's done this 100 times already work it through? It's a little different, right? So doing it yourself before I do is a way to test yourself of what you know and any little mistake that you might make, right? Yeah. So like forgetting to flip the negative, right? Forgetting to flip the sign. That's a big one on long division. All right. So I should be feeling pretty good about this. We got All right. We got a little bit less than 30 minutes. So let's go on to the second half, which is holes. And by the way, here's the this one is graphed, and then the slant asymptote we said was y equals 4x plus 3, and we can see it just just kind of just hovers to the right of it, right? It's pretty good. Okay, so um, after we're done today, you should know how to find the HA, the VA, the SAs, and we're going to go over holes right now. Holes are cool. All right. All right. So holes are pretty simple. So we're going to skip. We'll come back to HAV. Well, we'll do VA today. We'll do V. So not today. We'll do VA and holes together. And here's the reason why. So in your notes, you might want to maybe put a bracket around VA and holes, because VA and holes, they're sort of related, and we're gonna see why. We basically use VAs to identify possible holes. All right. When finding possible holes in a graph, and they may or may not exist, we have to do some work. We can't just look at a rational function and say, oh yeah, we definitely have a hole. Like SAs, you can do that. We can look at them and say, hey, that's a 2 and that's a 2. So class, real quick, does number 5 have an SA? Yeah, SA does not have an SA, because the powers are the same. Remember, the power must be one higher. So like on our TGA, we would just put none, right? There's no SAs in this one. Actually, let's do HA2. This is a little refresher. You recall from yesterday, what is the HA of this one? What is the HA of this one? Y equals -2. I would agree with you. Yeah. Yeah, this is an even rational function, right? The powers are the same, so you take the ratio of the coefficients. So -2 divided by 1 is -2, right? Good. Okay, so I lied. We're doing HA and SA as well, but they were obviously really quick. All right. When doing VA, what we need to do is factor everything. You must factor the numerator and we must factor the denominator. So again, hopefully you are pretty good, pretty solid on factoring polynomials at this time in your math career, being in pre-calc. You should be. And if you're not, I had people message me on Skype or email me, say, hey, can you send me some other resources to review factoring polynomials? And I will. So what I do is I go on YouTube or Khan Academy and I screen a few videos that I think are really good, and then I'll send you some videos on this concept from from last year or the year before, right? To review. So if you just ask me, I will screen them for you, and I'll send you some videos as a refresher if you need those concepts, because I can't. Pre-calc is jam-packed. I can't teach every old concepts that we need. It's expected that you know it, and I do review it a little bit, but maybe not enough that some of you might need. But anyway, with all that said, how do we factor the numerator? What's the first thing we should do? And I did say this yesterday. GCF, yeah. So very good, yeah. So Noah, Philip said it in chat. Lilani, yeah. So take out the GCF, which is -2. So remember, if you can pull out a greatest common factor, you need to do that first always, no matter what the function is. You always GCF first. If you can, we can pull out a -2. So that's what we do, right? That's what we do. And you should get that. And a good way to check, once you pull the -2 out, just real quick in your head, just distribute it again and make sure if we do -2 times all three of these, you get back to the same problem. Yeah, we do. -2 times this is -2x squared. -2 times +5x is -10x. And then -2 times +6 is -12. So just a little quick check to make sure what we pulled out and what we left over is correct. All right. How do we factor the denominator? X squared minus 4. Yeah, so it's the difference of two squares. So Noah put the right answer. It's x plus 2, x minus 2. Yeah, this is everyone should see that and say, oh yeah, that's a piece of cake. This requires little to no thinking whatsoever, right? Maybe 1 second of thought. And we all should know this is x plus 2, x minus 2. All right, so real quick before we kind of go on with the factoring, VAs. How do we find VAs again? Let me remember. How do we find VAs? Remember, guys, anybody can take the mic whenever you want. You don't have to ask. Don't feel weird interrupting me. So if you don't want to do it in chat, feel free to take the mic. I definitely encourage it. Yeah, so Naomi said it, I think the best is set the denominator equal to 0. Yeah, and so did Maria. Yeah, we set the denominator equal to 0. So when we set, this equal to 0, we're solving by factor. What are the VAs to this problem? What are the VAs? Remember, VA is vertical equate. These vertical lines should be in the form of x equals. So if you put y equals, those are horizontal lines. Those only apply to HAs. So VAs is always x equals if they exist. So yeah, so x equals 2, x equals -2. So I'm going to go ahead and write these down for our VAs because we can see those, right? So on your TGA, if you wrote for the VA, you said y equals 2 and y equals -2, I will mark them wrong. Even though you obviously got the numbers right, y equals is a horizontal line. These are vertical lines, vertical asymptotes. Anyway, now for the wholes part. Let's continue to factor this. So how do you factor x squared plus 5x plus 6? How do we factor that? Yeah, simple. I call it simple factoring. Maybe it'll rub off on you guys. Yeah, simple factoring, right? Two numbers that add up to 5 multiply to 6. I think you all can do that, right? So we get this. All right. Now you ready for the fun part to actually identify the whole? Everyone ready? Everyone's paying attention? Because this is the crucial part. Once you do all the factoring, we now can see the whole. So make sure everyone's paying attention. The whole, what you're going to do is look for the common factors. So if you see, we have x plus 2 on top and x plus 2 on the bottom, right? So those are the common factors our numerator and our denominator share. So, mathematically, they can cancel out. Would you agree? Like if you factor, they could cancel out, right? That'd be okay. And because they cancel out, they don't make an asymptote. They make a hole in the graph. So the hole, what we're going to do is once you identify, the matching factors, in this case, we only have x plus 2 and x plus 2. It is possible we could have more than one matching. Like let's say We had x minus 2 on the bottom, and let's say we had an x minus 2 on top. Well, we would have two matching pairs, right? But we only have one in this case. So what we're going to do is you're going to take that factor and set it equal to 0 and then solve. So I would say, and this is for the work for the wholes. We're going to say x plus 2, that factor equals 0, and then we solve, subtract 2 both sides, so we get x equals negative 2. So this is the first part. Now, wholes are coordinates. So in your notes, you want to write, wholes are coordinates. So it's not x equals or y equals. It's not an equation. It's a coordinate. And coordinates must be an ordered pair. So the x value is negative 2, right? X value is negative 2. And then what we need to do is now plug this negative 2 into we're going to plug it into the reduced function. So let me just erase this. And we already said, well, remember, these can cancel out, right? So what we're going to do is we're going to plug in negative 2 into what's left over to find the y value. So we're going to have on top, we're going to have negative 2 times, remember the x value is negative 2 plus 3 over negative 2 minus 2. So we're just going to simplify that. And we get, let me change my pen color here. We get negative 2 plus 3 is 1. Negative 2 minus 4 is negative 4. Negative 2 times 1 is negative 2 on the top. And then over negative 4. So then we get negative 2 divided by negative 4 is positive 1/2. So that is the y value. The y value is 1/2. So remember, wholes are coordinates. And I'm pretty sure that if you were to take the original, and if you were to plug in negative 2 into the original, I'm pretty sure, at least it should give you the right answer. I don't think it's going to make you, it might say divide by 0 just because we haven't canceled those out. I really don't know. I guess it depends on the calculator and how it crunches those numbers. But this is the safe way to do it. We factor everything, we identify the matching factors, and then set that equal to 0 to get x equals negative 2. That is your x value. These cancel out, and then we just plug in that x value into what's left over to solve, and that is the y value. So negative 2 comma 1/2. Now, one more step. So if you have a whole at x equals negative 2, that means we don't have a VA at x equals negative 2. So when you identify a whole, you have to erase or cross out this. Oops, get my pen tool out. We have to cancel out that. So we only have one VA. We have one VA at x equals 2, and we have a whole at negative 2 comma 1/2. So there is a little bit of work, right, to calculate the whole. So Naomi says, so x equals negative 2 is a whole. Well, at x equals negative 2 is a whole, but remember, we want the coordinate of that whole. So you have to plug in negative 2 into our function to solve to get the y value. So remember, wholes are coordinates. Yeah. So no one brought that up yesterday. And I didn't want to bring that up yesterday. And I think some problems I said that there was more than one VA. Well, there might be more than one VA, but when you graph it, you can see. So I think I have this graph on the next page. On this page, actually. So Yeah. So if you graph this, right, if we type this into Desmos and we get this curve and this curve, and then without finding the hole, we said the VA was at x equals 2 and x equals negative 2. Well, here's the one at x equals 2. And visually, we can see, yeah, x equals 2 looks like it's completely correct, right? And then if we didn't check the hole and we just said the other VA was x equals negative 2, you would create a vertical line that looks like it passes through the function, and that is a giveaway that that is not a VA. So if you kind of you skip the check, like if you don't want to factor and you find your VAs and you said, oh, vertical line here and a vertical line here, but hey, it looks like it passes through my function. I would say more than likely it's because it's not a VA and it's actually a hole at x equals negative 2 in this case. And then we just have to plug it in to solve for the y value. So in Desmos, I graph this. I think in PowerPoint, I had to add my hole here. So Desmos or whatever graphing tool you use, like a TI-84, Inspire, they won't show you the holes on the graph. So don't assume because it graphs it, it means that there's no hole. It's just a limitation of Desmos and other graphers that it can't show where the holes are. So that's up to you to identify. All right, how are we feeling about this process of finding the holes? It's a lot of work, kinda. Yeah. So can anybody? I'm just curious. Can anybody verify for me? Um, if you plug in -2 for the x value in your original function. So everyone, if you can quickly do that for me, and then hit enter, and let me know if it gives you undefined or if it gives you 1/2. I'm really curious. I really think it's dependent on the model that you're using. All right. So Philip says he gets a math error. Anybody else want to see if you get a math error too by plugging a -2 into the original function? And Philip, which model calculator did you use to get that? Anybody else actually typing this in for me? So we have 13 people in chat and one person typed it in. So just tell me in chat if you're actually typing it in so I know not to waste time. Okay. Okay, we're still typing it in. All right. So, guys, again, hopefully you all have, like, Noah has the FX300. I think that is a fantastic calculator to get. That one costs $10 on Amazon. Um, if you get the FX300, you're going to be good this semester and definitely next semester. You guys, you really need one for next semester if you're kind of prolonging it. Yeah. Anyway, okay, so let's go on. Philip said he typed it in to his FX, his Casio model, and it gave him an error. So it's safer than sorry. You're going to have to make sure you factor. We have to cancel out x plus 2 and x plus 2, and then we plug in that x equals -2 into what we have left over for this x and this x to solve for the y value. It's not that much work, right? Not that bad. All right, let's do. I'm gonna look at my examples real quick and see. Number 6, number 7. All right, let's do number. We'll do number 6. We'll do number 6. All right, I'm gonna give all of you. How much time do we have left? We got about 7 minutes, so I'm gonna give all of you. We'll say 3 minutes to do number 6, and this will be our last example of the day. I'm gonna ask individually, so don't put everything on the screen yet. I'll ask what the HA is first once the time runs out. All right, what is the HA for this problem? What is the HA? Very good. Y equals 0. Yeah, this is bottom heavy. So all bottom heavies are HAs. Y equals 0. Very good. Let's skip down to the SA. What is the SA for this function? Yeah, none. Yeah, there is no SA for this because the power in the numerator isn't one higher than the bottom. So yeah, there's no. What are the VAs? What are the VAs? X equals 3 and x equals -3. And then my last question are any of those VAs actually holes? No. Yeah. So holes, we would just, put none, right? Yeah. There's actually this one actually has no holes, and I wish I would have saw that before doing this one because, and if you graph it, right? If you graph it, and if you just look up visually, your VAs are at x equals 3 and x equals -3. And we can see that, this vertical line, yeah, definitely a VA, not a hole. It's actually an asymptote, right? And then x equals -3, same thing. This is definitely a asymptote and not a hole. And then our y equals 0. You can see right here, this is definitely a horizontal asymptote, right? So yeah, this one actually has no holes. Yeah, that was kind of boring. Let's, but I did show the factoring. So, you factor, you should have got that, right? You pull out a -2, we get x squared minus 9 inside, difference of two squares, x plus 3, x minus 3. Let's look at number. Okay, this one should have a hole. We have time? We got 2 minutes. Let's quickly just do this one because we got 2 minutes. I'm going to show the graph first. And I'm just showing this is the answer, right? We have a vertical asymptote, we have a slant asymptote, and we do have a hole. So let's kind of quickly just run through this problem. So the HA, this one is it's top heavy, right? Right, top heavy, x cubed versus x squared, top heavy. So HA is none, right? Yeah, so we don't have any HAs, and this was a lesson from yesterday. VAs, we have to factor, right? We have to factor that. So there's, I did the work real quick for you, but we can see that we can see that. Okay, so this is kind of deceiving at first glance. So we see x plus 4 and x minus 4. They are different. So it means they're not matching, right? So don't be tricked by seeing these two. And don't forget about our single term factors. So we have an x here and we have an x here. So x and x, remember, x is a factor, x plus 4 is a factor, x minus 3 is a factor, -4 is a factor, x is a factor, x minus 4 is a factor. So remember, factors and factors, x and x, those are the like factors. So we would set those factors equal to 0, right? So and this is talking about the holes, right? So we have a hole at x equals 0. So that means the VA, what's the only VA we have? X equals what? Yeah, x equals, what's the only VA? X equals 4. There you go. Yeah, x equals 4. Remember, if you have a hole at x equals 4, it cannot be a VA. So it's either going to be a hole or a VA. And because we have a hole at x equals 0, we can't have a VA at x equals 0. So then what we're going to do is looking at this reduced, remember, we x and x cancel out. So you're going to plug in 0 into all of the x's that remain. So we're going to have on top, we're going to have 0 plus 4 times 0 minus 3 all over -4 times 0 minus 4, right? So, 0 plus 4 is 4, right? 0 minus 3 is -3. And then -3 times 4 is -12. And then 0 minus 4 is -4. And then -4 times -4 is +16. So this reduces to, looks like 4 goes into 12 3 times, and 4 goes into 16 4 times. So -3 over 4 is the y value. So the coordinate is 0, -3 over 4. So that is the hole. Yeah, sorry, I wish we had a little bit more time to work these out. And then the SA, I don't have time to do this one, but it is long division. So we'll stop here, leave it at that, and I'll have you calculate the SA. But the SA, do I have the answer to the SA? No, I don't. Unfortunately, I don't have the answer on the screen. So you have to find out the SA, which is the dashed line here. Well, guys, sorry we're out of time, but thanks for coming. And as always, I hope you learned something.